Hello and good morning, everyone, or good afternoon for the folks joining in from Europe. Uh, Welcome to today's webinar hosted by Kalkitech. I'm Midun from the marketing team at Kalkitech AAC Systems. We are leaders in grid communication solutions. So today we are going to discuss about leveraging platform enablers for UL 1741 hyphen SB IEEE 2030.5 CSIP regulatory compliance. This webinar will be a touch upon the latest in UL 1741 SP and CSIP standards, as well as explore the intricacies of communication protocols like IEEE 2030.5, DNP3, SunSpec, and Modbus. A couple of hygiene points before we start off this webinar. This is going to be a 45-minute session, which will be followed by a 5 to 10-minute Q&A. Please note that this is also a listen-only webinar. If you would like to ask any question or have any query, feel free to ping them or message them in the chat screen. I will consolidate all the questions and have it answered towards the end of this webinar. If in case we are not able to answer every question, we will get in touch with you personally and try to address all your queries. Of course, a recording of this webinar will be sent automatically through the GoToWebinar application and shall be sent to all the attendees in around 24 to 48 hours time. We will also be emailing you a webinar participation certificate, an e-certificate, in a separate mail. All right, so now let me introduce you the host for today's session, Biju AS. Biju is a product manager in the Energy IoT division at Kalkitech AAC with over 20 years of experience. An experienced electrical and electronics engineer with key interest in standards-based integration in the renewable energy as well as wide area distribution automation. Biju specializes in smart inverter-based electrical network management systems for utilities as well as independent system operators, and has worked on large consulting and implementation projects across the world. All right, so without further ado, let me bring Biju on this webinar. Biju, over to you.
Thank you, Midin. It's wonderful and welcome all. Good morning and good evening. Those who are attending from India. Um, it's so let's start the discussion and webinar on this topic. So basically, we all know that standard and its compliance is very much required for utility projects, and UL 1741 and IEEE 2030.5 are widely deployed in North American DER environments. So I will be giving an introductory session on these two major standards. Then we will move on to platform enablers that will support OEM as well as utilities uh, against these particular standards. So let's move on to the topic. So the overall agenda split into different topics. Background, I will give an introduction to DER and our offerings, then integration options. How do we support OEM or utility or those who are interested in this domain? And how do we select different aspects of platform enablers further on if you would like to enable that standards in your products or requirements, and followed by a small Q&A session. So let's start with the background. So we all know that traditionally power, when we talk about power flow, it is actually flowing from a network to the user or a residential or commercial environment. That is how it typically happened. So in that aspect, in olden days, we don't have any energy resources. Only what we have it is actually a load. So now what has happened is that recent advancement in technology and other aspects, commercial viability, people are started adopting more PV at their residential aspects as well as commercial uh, environment. So that the concept of introducing energy resources actually called distributed energy resource. So that changed all the aspects of electrical distribution network. So traditionally, as I indicated, power was flowing from top to bottom. Now we have a situation where energy resources are sitting at the bottom of the line or behind the meter, start giving the power back to the utility. So this creates a lot of problems, and it need to be mitigated at different uh, scenarios. So when we talk about DER, we can see that there are PV plants. Now we have battery energy storage systems, or in future fuel cells may become. So all are sitting basically behind the meter and start supporting the network. So this is a prospect aspect as well as there is a problem aspect. So utilities are now thinking the mitigation parts or how to utilize it better. So we need solution for that. So so basically when we are talking about DER interconnection, there are different aspects to it. And now previously it was just an interconnection with without any consideration. Now it has been evolved into multiple features. So now what happened is that previously uncontrolled resources was there. Now utilities are thinking about how to control those particular assets available at the residential or commercial backbone. So we need a better communication with to utility as well as the application part of it. So utility may come up with a different application with respect to DERs. So we need to have a better visibility of that devices for the future requirements. So this comes to interoperability requirements. That is where these two standards come into picture. So IEEE 1547 is a widely accepted standard for smart inverter platforms, and it covers most of the electrical requirement in nature. Uh, then what happened is that it's a common standard. So basically, UL took that standard and applied into the uh, uh, testing aspects and converting into that into a what we call practical aspects into that, and deployed as a another standard is called UL 1741. So UL 1741 is actually a subset of 1547, and with all the other what we call uh, conformance requirement test procedures or the safety aspect to it. Then, as we indicated earlier, uh, there was a requirement of communication. More and more standards got evolved. IEEE 2030.5 is one of the major standards evolved and practiced in North American governments. So this also got adapted into UL 1741 in new supplement SB. So this actually uh, mandate the requirements of certain protocols like 2030.5 and or IEEE 1815 DNP3 or SunSpec Modbus. So it's not only covers electrical aspects, but now started covering the data part of it. Now let's get into the details of 1741 uh, supplements like A and B and what it covers. UL 1741 supplement A actually covers electrical aspects of it much more in a lower perspective. Like if you take a functional aspect of it, is actually it's covering uh, very few functional like volt var, anti-aliasing, low I, uh, LVRT, HVRT like that. But when it comes to SB, it covers more and more functionality into it and uh, defined a protocol for that. Then basically what happened is that behind the meter system need to comply 1741 SB in a more standard way. So we have a certain set of protocols and data has been put forward. So we'll discuss about that. So in US, North American, uh, in North American environment, basically we can see that most of the utilities are adopting 1541 as well as 1741 SP in a mature way. So you can see that almost all the utilities are actually planning to adapt the standard and move forward. So what is the benefit we are getting out of or having a standard rolled out for a utility? So basically we can see that these integrations will give more visibility and in terms of capacity, in terms of inverter settings and its operations. And basically this will standardize interoperability requirements within the utility. So by having that one, utility can now basically mitigate network issues or electrical network issues or ability or for the dispatch function, or they can actually utilize the asset sitting behind the meter for a large uh, requirement like grid resiliency, or we say fluctuations or system wide faults or something like ancillary service, or if you want to find out the capacities or what is available reserves within the system, basically we can analyze with this data what we are getting from through uh, new interfaces. So when we discuss about standards, now we already got an idea about what is a standard and why it is required for the utility. Now, in terms of OEMs, how do we see the standard? So basically, this is a smart inverter platform, and basically that need to be comply to the standard when utility required. So how do we achieve that? That is the problem right now. So in order to have that one, these platforms need to be compliant to the IEEE 1547 or 1741 SB compliant by using certain communication protocols or a set of data exchanges. So what platform enablers actually do is that enable a inverter platform which is not compliant to the these two standards by using different methods. So platformable, and there are three types of platform enablers we are foreseeing. So one is using existing platform with a software approach where we integrate the softwares that is compliant with the 1741 within the inverter platform. So basically what we do, we supply a software that integrates with the inverter or sits inside the inverter platform. Another option is that we provide a hardware platform that is actually uh, integrate with the existing inverter platform that are actually uh, integrated by a hardware, and expose the data or features to utility via compliant protocols. Or third option is actually have, if the inverter platform does not have the provision to accept a new software or a hardware, we support it via a gateway or a equipment which sits outside and integrates with the existing platform and provides the data to the utility via uh, standard protocols what we that are compliant with the 1547 or 1741. So these are the platform enablers which will support OEMs or uh, the inverter manufacturer who could actually enable their platform for the compliances. So we will discuss about the our offering with more detail. So what are the options? Options right now we have it actually a software based system which is actually a container based application uh, which can support IEEE 1547 based uh, communication and expose that one into utility platform. Or second option is actually embedded module that can integrate directly with the inverter platform via standard links and expose data to utility. Third option is actually gateway, which again uh, connects utility system and which can integrate with the uh, inverter platform. So these are the three independent solutions. That way we can actually achieve 1547 compliance. So all these particular features, all these particular options are built in with the security and connectivity management facility. So let's understand the offering bit more in detail. In terms of hardware, as we indicated that uh, the module itself is actually can communicate uh, to other inverter platform via TTL or I2C or any standard interface available within the inverter platform. And further to that, this particular platform can send data to utility via standard protocols what we earlier discussed. Either it can be SunSpec Modbus, DNP3, or IEEE CSIP. So these are the hardware platform uh, capability. Then we move to software. Basically, it's a container application that can actually sits inside the inverter platform and integrate it. So we have a 2030.5 server, then DNP3 or Modbus, which is the protocol suited to that environment. Basically, we can choose and integrate it. And further to that, what we can do is that we can actually give the consulting for integration of these particular software and hardware with respect to the manufacturer, and we can guide you the testing procedures, and we, even conformance tests we can plan and we can meet the requirements. So we are actually giving complete consulting for that particular act. So bit detail about this three enablers in details. So we can see that a system architecture has been put forward. Okay, so you can see here, this is our Kalki IO Edge sitting inside the smart inverter platform that is actually integrated with the existing manufacturer in inverter software platform. So we uh, what we do is that we can communicate with the inverter platform or MQTT or using API or a standard based existing protocols that is existing in the inverter platform can be used to communicate with the Kalkitech Edge solution. So once we have the data over here, we can map to the uh, respective protocols, DMP3 or 2030.5 or SunSpec Modbus, whatever is required, that we'll convert, and basically we can send this data to utility systems. So utility at their side can receive this data and over any of this protocol and do necessary application on top of it. Maybe a SCADA system or a terms system sitting on top of utility uh, aggregator or utility software. Uh, so minimum requirement for this particular software approach is indicated over here. So the platform is on Linux, uh, and Debian or RPM or Docker based solution we can provide, that whichever is suitable for that one can be fit into that. Then the minimum specification hardware is indicated over here. Uh, Basically, this has to be meet for this particular application to run. Now we talk about the hardware platform, uh, which are required by the OEMs whenever there is a case uh, when they don't have enough capacity in terms of adopting a new software into their system. Basically, at that time, we have to have a external hardware to integrate with the inverter platform. So we can use existing whatever is available like TTL or SPA or I2C for connecting to embedded module, then expose this particular data back to the utility for integration requirement. This way, basically, we can meet the standard requirements. So after uh, converting those data into these particular protocols, the data path will be same as it is. So in in case again, I want to indicate that if inverter platform need to exchange the data to existing cloud, so basically they can use the same link to transfer the data uh, to their or cloud solutions uh, with without disturbing our existing hardware module. So this we can have those two data pathway for in case manufacturer required to store the data in a cloud, their own cloud, that we can meet it uh, by using this particular integrations. Now, basically, um, the third approach, basically what we are seeing is that when inverter does not have a capacity or adapting a new software-based solution for standard requirement, or they cannot integrate hardware module with their system, then basically they have to go for an external gateway-based approach where they can uh, connect their data to an external device from our side, and uh, using protocols what they basically what presently what they have it, actually maybe a Modbus or maybe a DMP3, whatever it is. Basically we can take the data into our system, then we can convert back into uh, basically uh, a compliant based data structure and transfer that one into utility requirement. So this is the third option when other two options are not viable. So you can see here uh, the data path, the utility side is same. So basically we are enabling the OEM platform with different approaches to standardize it. So in terms of solution, what we are providing is that we have a Kalki.io Edge platform that can integrate with the uh, smart inverters or controller or platforms what they have it, and expose this data into utility side using a standard approach, which is mentioned in the standard like IEEE 2030.5 or DNP3 or SunSpec, whatever is required. Based on that requirement, we can expose the data. So within the system, we can use MQTT or Sync API, whichever protocol required. We can use that to get the data from the system and expose that. So So basically, when we are talking about the software solutions, it has to be actually have to be complied with a different security requirement. In that, uh, PKI infrastructure management is one of the key aspects. So we have different options for uh, securing the codes. From three options are there. Basically, trust chain one, where we can sign in our all the software within our infrastructure and get it signed, and we can have a stage-wise, I will say, stage-wise control for the firmware releases. Basically, we can use testing one signing, so that basically what we are ensuring that whenever we have a complete development cycle completed, that package only goes into inverter platform. So we can ensure uh, security in all the stages, and only the correct firmware will be loaded into system using this infrastructure management. So non-installable is actually we will be signing the software within our infrastructure, and we'll be maintaining that. So second option is that that particular infrastructure is actually sitting within the uh, private environment, or basically the environment provided by the OEMs, and we will be uh, utilizing that one as a signing method. So there is basically uh, we will be controlling our user interactions with that using role-based access and all. And third option is actually where utility have an infrastructure where they are maintaining this all the firmwares from their own side, and basically they are providing the security chains within their infrastructure. So in that case, we can have the security management linked with that, and do the firmware upgrades. So it is basically it will uh, so utility have their own environment, and we are matching with that, so that way it is more secure, and we'll be able to provide that. This is the trust chain option 3. So to ensure security in all aspects, we have a hardened platform for software as well as uh, hardware platforms, and we have different what we call different options and different methods to ensure that this is actually protected from all aspects of malware or any hacking or external um, intrusions. All are prevented from using firewall to sandboxing and distinguished stages for the signing of the software development. So all aspects has been covered in our basically the solutions. So we are uh, hardening our solutions in all aspects and protecting from malware attacks or any other intrusions. So we have firewalls, we have secure boots, sandboxing options, and administrations like role-based access. Everything has been provided for all the enablers. So in all, we have a if you see from the top to bottom approach, so we have TPM and secure for boot, boot access control, hardened Linux software, firewalls, and sandboxing on, and how all are actually in a aligned in a such a way that we are protecting all the attacks and all the security, we are including all the security features. Then on top of it, we are providing protocol services that is required by the standard to ensure that that is compliant with the utility requirements. So in terms of protocol requirements, basically what we have is tabulated over here. So utility side, we have IEEE 2030.5. This is actually complied with the UL 1741 supplement B, and DNP3 side, we have a IEEE 1815P. That is the equivalent standard in DER side. Then other protocols like 6150, 103, 101, all are available utility for the utility connectivity. So specifically, if you take out the DER aspect, uh, IEEE 1547 is actually indicating 2030.5, SunSpec Modbus, DNP3, all are there in available from our side. Then, in addition to that, OCPP, BACnet, one of our, if any of these interfaces are required for any applications or that is required by uh, other uh, application owners, so we can provide that, maybe a utility or maybe a market operator. So all are possible from our device enablers. So basically, for IoT side, we have OPC UA, MQTT, and integration side, we have Amazon AWS. So all the required protocol interfaces are already available with the platform. So whenever it's required, we can enable it. So connectivity side, we already have SNMP, NTP, SNTP, time synchronization protocols, IRIC-B. So depending depending upon the requirements, we can enable those protocol features. So when we compare the 1547 protocol compliance, we have three major protocol has requirements has been indicated. That is SunSpec Modbus, DNP3, and IEEE 2030.5. So these are actually not just protocols or data exchange. These are the settings or the functional requirements that is indicated in the 1741. So it has to be so these protocols support those functionality aspects as well as the communication requirement. So you can see here SunSpec Modbus, basically an address-based protocol which define a certain register sets for every functions, and then it is connected to that particular information is passed on to utility requirements. So uh, that that is for SunSpec Modbus. Then DNP3, basically it is again a address-based system, but again it is having its own protocol capabilities that is better than SunSpec Modbus. That is also covering the DER aspects. Then when we come to IEEE 2030.5, this is a profile-based system where which having a large messaging capacity, and you can see here from the comparison, it covers more functionality and features with respect to different standards, different protocols. So we can see that these three protocol enable the requirement, but in that IEEE 2030.5 is utilized in California Rule 21 requirement. So basically, uh, we are basically following IEEE 2030.5 as a major protocol compliance for our products. So in that aspect, see our platform. is compliant to common smart inverter profile uh, requirements, and there are the functional set which is actually certified by the SunSpec. So we have time, we have device capability, we have end device. So these are the standard specific requirement that need to be compliant and certified by the authorities. So every manufacturer has to comply to that. So we are certified environment that basically supports your enablement process. Uh, in terms of features and supports for flexibility of protocol mapping, we have any to any mapping features. Basically, we can convert, say, if inverter having SunSpec Modbus and that need to be converted to 2030.5 requirement, then we can do easily via mapping, flexible mapping requirement. So basically, what we are saying that uh, any end device can have any protocol and which can convert into a standardized requirement that we can do from our side. So you can see here SunSpec Modbus can be converted into 2030.5. Similarly, DNP3, if a device supports a DNP3, basically we can actually convert that one into 2030.5. So similarly, if it is 6150 protocol, and it can also map into DNP3 requirement. So anything is possible from our side. So that's how the data mapping is done in our product environment. And so in addition to the protocol and standard compliance, we also provide device management features. That means we integrate our software or hardware into the system, then that particular device can be managed remotely or analyzed remotely. So we have a monitor application for the health. We have a end device communication. We can indicate that this particular device is working fine or not. And if for the DR environment, basically the assets are distributed over a wide geographical area. So uh, we we can provide a centralized management facility for all the device which is enabled from our side. So we can do dashboard for we have dashboards for the entire uh, platform, which will show how many devices are up, down, or what is this, uh, or how many data it is reporting. All those features we can see from our device management perspective. So that is key feature in our side. In addition to that, we have notifications. If you want to notify that okay, this particular site is down and we need a notification. Basically, all this particular aspect is covered in our device management uh, features. So another uh, I will say another feature from our side is actually we can manage all these particular enablers remotely. So if you are sitting outside and you want to change the setting, or you want to patch a particular uh, software, then we can use our remote access facility and do the configuration change, and we can enable that particular feature without going to site. So this is also a um, uh, very well very much required for the assets which are distributed over a large geographical area. So we cannot go every site and do the changes or for a particular requirement. So that is already incorporated as part of our product. So we are not just providing a single piece of software. We are actually covering all the aspects of the enablers. So it's include configuration, upgradation, diagnostics, whichever is required, that is covered in our side. Okay. Uh, So if we move to the next aspect, basically data coming from uh, these inverters not only required by the utility, it may be required by the other players in the market, maybe a market operator or energy market. So we have we can send those data, whatever it is received from these inverters, into that particular uh, application or or an a device which is sitting outside the utility. So in that case, if you if particular OEM does not have a platform for that, we have a cloud-based solution where we can receive the data from these particular inverters and aggregate that data and send to different uh, I will say different players or different application owners. Like in here, it is a market application sits on outside the utility perimeter. Then basically that data will be passed. So if they have a particular requirement or data sets need to be passed, we will be enabling that particular channel for them. So same data can be also passed into uh, utility side. There they aggregate the data and process it for their requirement. So what we provide in terms of services, we we provide consultancy for enabling uh, these enablers. We will sit with the OEM platforms or utility side to understand their requirements, and we give these details about how to go forward and all those things, and hands-on sessions. Understanding their problems and how do we approach those problems, all are included in our consultancy phase. And implementation phase, uh, we do design and development software according to the inverter platforms what manufacturer have, then implement as per the guidelines of UL 1741 or IEEE 1547 requirements, and we review together, and we'll ensure that interoperable communication is achieved with the utility side. And third aspect is testing, where all the conformance test support we'll be able to provide. And basically, we have a testing tool and environment that will support simulating wherever it is necessary. So we'll come to that particular aspect. So we have a simulator. So this is where we are saying that we are a complete platform enablers, where we can implement the requirement at the platforms or OEM platforms whenever it is required. Then we are also able to test it completely. Like uh, we have ensured that that particular compliance is achieved through all the aspects. So we have utility system simulator, we have device simulators. So with all these particular portions will ensure that the product is completely compliant with the standards or utility requirements. So in addition to OEM side or the smart inverter side, if they would like to test or they would like to become a aggregator for the utility, then what we provide is that we can test. We will be able to provide a complete testing and validation suite uh, for ensuring inverter profiles are compliant with a standard or utility requirement. In this case, basically, we have test portal set up that will uh, completely cover the uh, CSIP compliance requirement, and um, we'll be able to show the results as an aggregator and how it is performing, how their inverter data is coming to system, which are the functions that they are able to comply, which tests are failing out. All these particular aspects has been covered in this validation tool. So uh, this is a well set up enablement process, we are able to uh, comply the product from all aspects until testing. So yeah, so that's all. So again, when we talk about these particular standards, 1547 or uh, CSIP requirements, so there are certain factors need to be considered. Uh, that will be explaining in next slide. So one is utility preference. So if you take about North America, CA Rule 21, California Rule 21 requirements are actually explicitly saying that they are then every smart inverter platform need to be complied with the IEEE 2030.5 CSIP profile. So those are the certain preferences by the utility that need to be considered in advance when you are selecting the protocol. And regulatory preferences, like as I said, uh, standards like 1547 or 1741 SP that need to be considered while selecting the protocol. So there are certain features required by the utility that also need to be complied. So all these aspects need to be considered. And technical preferences, like utility may have a certain functional requirement in terms of, let's say, dispatch requirement or use cases which they need to satisfy. So that requirements also need to be understood properly before selecting the protocols. So that is where our consultancy plays a vital role for OEMs. So if we take an example of California Rule 21, so these particular aspects are covered in 2030.5. So that is one choice. We will be that is the ideal choice for uh, that particular utility. So this is one example. Similar to that, different utility have different preferences globally. So we have to analyze that particular requirements. Then we select protocols for that. So that's all from my side about the topic. So hopefully covered the platform enablers and their importance with respect to standard is given in some aspects. So it's an introductory session. If you take out each aspect of it, we need a more time to explain in detail. So yeah, that's all from my side. Yeah.
Thank you, Biju, for a quite detailed session. No doubt, of course, there are a lot that we can go and deep dive, but a very informative session, and thank you for that, Biju. We have a few questions from the audience, the people who were there. So one question was with regards to the benefits. Like, so what is the benefit of IEEE 2030.5 over DNP3, Modbus, SunSpec, etc.?
Okay. If you take the protocols, if you understand it in a different way, Modbus and DNP3 are address-based protocol, and that is well established in market for a long time. And if we compare 2030.1, it's a profile-based protocol where we can have a large data exchange and more intensive functions. So I will say that this is one is utility already. Those protocols are already existing, and we are building requirements or meeting requirements uh, based on the existing platforms. Yeah.
All right, great. What's the estimated timeline for UL 1741 SB certification?
Approximately it is 10 to 12 weeks. That is the approximate time what we are assuming. Yeah. That again, it has a dependency on platform what OEMs have. Yeah.
Got it. Got it. Um, What are the additional support charges required for production after certification? That's one of the questions.
Sorry,
Changes. Yeah. What are the additional support changes required for production after certification?
in terms of supports.
Yeah.
Yeah, so basically we have level 1, level 2, level 3 support uh, functions are available. So depending upon the case to case, we are actually dealing. So customer can interact with the different levels whenever there is a requirement, and we will be resolving that issues. So we have a procedure for that, and we will be ex- explore. We will be giving that details to the customer once we have onboarded into our system. What when we onboard the customer into our site. So we have, yeah.
All right. There's one more question with you had mentioned that of course in the California area it is IEEE 2030.5. Um, what's about in the other regions in the US or North America? Is it like they are also going about in adopting 2030.5 or someone is something
Uh,
else?
Generally, it is 2030.5, but SunSpec Modbus is also available in those regions. But 2030.5 has as the utilities are more and more utilities are working on it. So there is a clear, I will say, follow up towards that. But if it is not existing, but still Modbus, SunSpec Modbus is available mostly. Yeah.
Got it. Right. I think that was the final question that we had received from the audience. Um, all right, great. So thank you once again. Thanks for everyone who had joined in. Of course, we'll be sharing this particular webinar recording via email via URL link that we sent, as well as, of course, you will get an e-certificate on the participation for this webinar. Great. Biju, thank you so much once again, and wish you all a very good evening.
Thank you all. Thank you all. Yeah.
Thanks. Have a good day. Bye bye.